So we're going to talk about how gas takes up space again, but right now we're going to focus on how something can go from a solid to a gas, which is called a phase change. We're going to look in particular at dry ice, and since it may be difficult to obtain, we're going to include several video clips of different things we do with dry ice that you can show to the class and talk about separately. They will not be accompanied by narration because you can talk about them separately, but we will provide some different information. So this right here is dry ice, and as you can see, it's a solid, but it's actively turning into a gas when met by heat. So when my hot air breath blows on it, it will go into a gas even more. You can also use a balloon to demonstrate that it can go from this solid form to a gas. So right now we have solid dry ice in a tube, and we'll place a balloon over the mouth of the tube. And over time on its own, it will blow up as the solid turns into a gas and the CO2 fills the balloon. However, if you want to speed this up for the class, if you place your warm hands on the balloon, the dry ice will start to convert more quickly and the balloon will blow up. This can similarly be achieved if you place warm water in the beaker, which we'll do now. So with warm water in the beaker, we can place the tube in, and you can see that the balloon's actively growing in size as the solid dry ice is converted to a gas. So while we've shown that the dry ice goes from a solid to a gas, and you can see that the level of dry ice is actually decreasing as it is going to a gas, we also want to show that it can go back to a solid. And the way that we do that is we use liquid nitrogen, seen here. And what's interesting about liquid nitrogen is that this is actually a liquid that's going from liquid straight to gas. So similar to solid to gas, it's actually liquid to gas. And it is very cold. So it's going to take this heated up air that's in the balloon, and when I stick the balloon in, we'll make it cold again, which will convert the gas back to a solid. So when I stick the balloon in the liquid nitrogen, the air inside is condensing because the temperature is much colder. The liquid nitrogen has a lower temperature than the actual freezing point of the air in the balloon, which is why it can convert back to solid dry ice. So once the balloon is completely deflated, you can turn the balloon upside down, and you'll notice that there is solid dry ice going back into the test tube. So after you show these video clips to your class, you can discuss a couple things that you've learned. First off, things do not have to stay in the same phase at all times. They can go from liquid to gas, like we saw with liquid nitrogen, or from a solid to a gas, like we saw with dry ice. Simultaneously, they can revert back to the state that they started in if you change the temperature again. So once we started with a solid with the dry ice and we heated it up, it converted to a gas. But once we cooled that gas back down, it returned to the solid dry ice state.